Hello, you're welcome back. All right, so the topic is binomial theorem. Okay, so what is binomial theorem and what do we use it for? Okay, so we use binomial theorem for the expansion of different degrees of a binomial expression. Of course, that a binomial expression is an expression that has two terms. All right, so we are going to begin this with expansion using Pascal triangle. Okay, so this is a binomial expression a plus b. So we are starting with the power 0, okay, raised to the power of 0. So anytime you expand, if you expand any expression to the power of 0 or any number to the power of 0, it will always be 1. Okay, so this is going to be 1. Okay, now let's look at the expansion to the power of 1. So if I expand this to the power of 1, I will simply have a plus b. Okay, now let's look at the expansion to the power of 2. If I expand this to the power of 2, I will have a square plus 2ab, then plus b square. Now, this is called Pascal triangle, as you can see. As I'm going down, as I continue in my expansion, you notice that the terms are increasing, okay? The very first expansion don't have started with 1 term, increases to 2 terms, then the third one increases to 3 terms. Now, with this pattern that is going on, we are going to derive a regular pattern in this expansion, and we are going to use it for expansion of a higher degree. Now, if you perform the expansion of degree 3, now what you're going to end up having is you're going to have a cube plus 3a square b plus, okay, plus 3ab square before you now finally have your b cube. So now let's look at the pattern that is being developed in this expansion using Pascal triangle. This is Pascal triangle. Okay, so as you can see, the shape is the shape of a triangle. Now the pattern that is being developed is, let's first of all look at the pattern that is developed for the two variables, right, a and b. Now, okay, the pattern that is being developed is that a will take the highest power of the expansion. Like in this case, let me use this last expansion to explain. A takes the highest power, which is, all right, then b actually takes the lowest power. So as we proceed, the power of a will be reducing. Okay, a takes the highest power and it will reduce, the power of a will reduce to 0. Okay, while b takes the lowest power, then the power of b will increase to the maximum power. So now, starting from the very first term here, a takes the highest power, which is a raised to power 3, then b takes the lowest, which is b raised to power 0. And you know that b raised to power 0 is 1. 1 multiplied by a raised to power 3 is still a raised to power 3. Then we'll now go to the next term. The power of a reduces by 2. It reduces by 1, please pardon me. So a now reduces to 2. So that's a raised to power 2. Then b increase from 0 to 1. That's why we'll have b. Right? B raised to power 1 is written as b. Then the next term, a reduces from 2 to 1. Then b increases from 1 to 2. Then finally, a reduces from 1 to 0, which of course a raised to power 0 is 1. Then b increases to 3. So that is the pattern for the variable. Now the question is, what happens with the coefficient? Remember, there's a coefficient, okay? How do we get the coefficient? So it is the coefficient. Now it is the Pascal triangle that will enable us find the coefficient. All right, so look at how we get the coefficient, starting with this. Okay, now please take note, the last coefficient, Okay, the first and the last coefficient is 1. Now, what matters is the coefficient between those coefficient that is between the first and the last. And how do we get the coefficient between that is between the first and the last? We get it by actually adding the coefficient of the previous expansion. Okay, so how do we get this two? The coefficient of A here is 1 and the coefficient of B is 1. So if you add 1 plus 1, that will give me 2. So now for this third this expansion here, A plus B raised to power 3. So how do we get this coefficient? Look at this middle term, all right? These two middle terms. How do we get the coefficient? So we always add the two terms. So this plus the coefficient of this plus this and this and this. Okay, A plus the coefficient of A square plus 2AB. The coefficient of A square is 1. Okay, and of course the coefficient of 2AB is 2. 1 plus 2 will give me 3. Okay, then of course 2 plus 1 will give me 3. So that's how we got it. So with that, now I'm very sure that you'll be able to understand how, all right, this expansion, the next expansion will be. All right, so let's start with the variable first. So this is going to be A raised to the power of 4, then B raised to the power of 0, okay, which is 1. Then of course plus the next is gonna be B. A now reduces to 3, then of course B increases by 1, right? Then I now go again. A reduces to 2, okay? A reduces to 2. Let me go. A reduces to 2. Then this time around B increases from 1 to 2. Then A reduces to 1, B increases to 3. Okay, increases to 3. Then finally, the last but not the least, A reduces to 0, which makes it 1. Then B increases to the power of 4. So now let's see how we get the coefficient of each of these terms. So the coefficient of this is going to be the sum of these two terms. 3 plus 3, which of course is 6. Okay, so that is it. Now the coefficient of this one here is going to be the sum of oh please pardon me, I didn't start that is wrong. I didn't start it well. You always start from the beginning, always from the beginning. The coefficient of a cube b is going to be the sum of the coefficient of these two terms. That is 1 plus 3, which is 4. Okay, please do it correctly. The coefficient of this is going to be the sum of these two terms. 3 plus 3, which of course is 6. And the last but not the least, the coefficient of the last middle term. Okay, let me the last middle term. Okay, it's going to be the sum of this coefficient, this and this. That's 3 plus 1, which of course is 4. So you can go on and on. All right, so now Pascal triangle actually form a very simple basis to which we are going to perform binomial expansion, okay, of any degree. But there's a problem with Pascal triangle, because if you look at this, if I am being given something like A plus B raised to the power of 10, I have to take my time to build the triangle to the point where I'll have the degree 10, and which is not efficient. Okay, so that is why I'm going to introduce to you the general formula of binomial expansion. Okay, so let's look at the general formula. Now this general formula is a formula that will enable us to find the coefficient. Already we know the pattern that is being developed for the variables. Okay, so now let's look at the general expansion of A plus B raised to the power of n. Okay, so now this is going to be equal to the very first coefficient is gotten by evaluating C combination 0. Please pardon me, is gotten by evaluating n combination 0. Please not C. Okay, n combination 0. N of course is the degree of the expansion. Okay, then of course A being the very first variable takes the maximum power. Okay, then B takes the lowest power, so I don't need to write it. B raised to power 0 is already 1. Okay, so then the next coefficient is gotten by n combination 1. So the power of A reduces by 1, while the power of B increases from 0 to 1. The next coefficient is going to be n combination 2. Okay. The power of A reduces by 2 this time around, while the power of B increases by 2. The next, it continues like that. The next coefficient is going to be n combination 3. The power of A reduces by 3, while the power of B increases by 3. So this actually continues to the point where we have n combination n. Okay. Then the power of n now reduces to 0. That is going to be the last term, while the power of B increases to the maximum, which is n. Okay, so that is what we are going to do. Okay, so I'm going to show you exactly, and we're going to use an example to illustrate the use of this general formula of the binomial expansion in the next video. So see you in the next video. Hello, you are welcome back. Alright, so the topic is binomial